Welcome viewers. In the previous class, I discussed the basics of logarithm, why the log operator is needed etc. Here, in this class, we derive the properties of logarithm with the help of laws of indices. In the previous class, we see that if a to the power x equals to m, then we can write x equals to log m base a, which is in the power is seated separately, and a is the base of logarithm. If we take a to the power x equals to m as equation 1 and a to the power y equals to n as equation number 2, if we multiply these two, a to the power x into a to the power y, we get the value m into n. From the basic properties of indices, we know that a to the power x into a to the power y equals to a to the power x plus y. So a to the power x plus y equals to m into n. We know from the basic properties of logarithm that which is in the power is seated separately. So here x plus y is the power of a. So x plus y is seated separately or individually. So x plus y is equals to log mn base a. So from the equation number 1, we get the value of x is equals to log m base a, and from equation number 2 we get the value of y is equals to log n base a. If we put these values in this equation, we get the value log m base a plus log n base a equals to log mn base a. This is a property of logarithm. Similarly, if we divide equation number 1 by 2, equation number 1 divided by 2, that is a to the power x divided by a to the power y equals to m divided by n. From the basic properties of indices, we know that a to the power x divided by a to the power y equals to a to the power x minus y. So a to the power x minus y equals to m by n. We already know from the basic properties of logarithm that which is in the power is seated separately. So here the power of a is x minus y. So x minus y is seated separately or individually. So x minus y is equals to log m by n base a. If we put the value of x and y, we get log m base a minus log n base a equals to log m by n base a. This is also a property of logarithm. We all know the formula a to the power 0 equals to 1, where a is not equals to 0. From this, we can prove another important property of logarithm. From this relation, we can write that which is in the power. Here, the power of a is 0. So 0 is equals to log 1 base a. So the value of log 1 base a is equals to 0. This is also an important property of logarithm. Log 1 base a equals to 0, where a is greater than 0 and a is not equals to 1. Now we see the other properties of log. The other properties of logarithm. logarithm. Log m to the power p base a equals to p log m base a. Here p is the power of m, so p is seated in front of the log. Log b base a equals to log b divided by log a. Similarly, if log a base a, the value of log a base a will be log a divided by log a, that is equals to 1. Another important property is a to the power log x base a equals to the value itself is x. If we take 10 to the power log x square base 10, it will give the value x square. If these two values are equal, here the value is a and here the value is 10. So we can write this value, here x, we can write it in the right hand side. Here the value x square, we can write it in the right hand side also. All these properties can be proved with the help of exponents. So we can say that logarithm and exponent function are inverse function of each other. Thank you for watching my video. If you like my videos, please share and subscribe my channel. Thank you.